This is the Spring Final Review, Unit 9, continued. So this is the last page of the Spring Final Review. So we're going to take a look at number 21 first. So for 21, I want to get a common base here. So I can get 4 and 16 both down to either base 2 or base 4. It really doesn't matter which one I use. So I'm going to go ahead and just bring them to base 4 since this is already to base 4. So this would be 4 to the power of 3x plus 5. And then I want to rewrite 16 as 4 squared, and then that is to the power of x plus 1. So now that they are both to a base of 4, I can go ahead and solve for just the exponent. So I'm going to pull down, extract the algebraic equation, so that would be 3x plus 5. And then here I want to make sure that I distribute the power of 2 into the power of x plus 1. So I would have 2x plus 2. And then once I do that, I want to isolate x. So I'm going to go ahead and subtract 2x from both sides. And then to get x by itself, I'm going to subtract 5 from both sides. Okay. And then let's take a look at number 23. So for question number 23, I am going to divide the 3 over. So I can't multiply the 3 and the 5 together because 5 is being raised to a power. And then rules of exponents or order of operations means I would have to find that exponent value first before I can multiply. And since I can't do that, I'm going to divide over the 3. And then I would try to get these to a common base. So this is a base of 5, and this doesn't have a base other than base 10, right? So I can't do like 2 squared or 3 cubed or anything like that. So that means I need to get x by itself. So the only way to get x by itself is to get rid of the base of 5. And to get rid of the base of 5, I want to take the log of both sides, and I want to do log base 5. So I'm going to take the log base 5 of both sides of the equation. And then over here, this will cancel because those are inverses of each other. And so then I have x plus 2 equals log base 5 of 10. And so I don't know what power of 5 will create a 10, right? So certainly not a whole number, like 5 to the first is 5, 5 squared is 25. So then I need to leave it like that. And so then now I want to get x by itself still. So I'm going to subtract 2 from both sides. And then when I subtract 2, I'm not actually subtracting it from the 10, right? It's from whatever value that is. So I can put the negative 2 first. And then that indicates clearly that negative 2 is not combined with the 10. And so then I would just leave my answer like that. Okay. And then let's take a look at number 25. So for question number 25, I, again, want to isolate the x. So to get x by itself, I need to get rid of the 5, the e, and the 7. So I'm going to start with adding the 7 over, because when we're solving, we want to peel away each of those values. That's from x, right? So we start with the furthest first. So 43 plus 7 is 50. And then again, I want to divide by 5. And then to get rid of base e, I need to do logs. So I want to do the log of both sides, but in this case I want to use base e, so that means natural log. So I'm going to take the natural log of both sides of the equation. And then these are inverses, so it leaves just the x. So x would equal natural log of 10. And then let's take a look at number 27. So for number 27, so this time I am solving for logs as well, except for I have multiple logs, right? So I need to combine first before I can try to start to solve. So in order to combine these two logs, I have an addition. So when we combine logs, that means we are multiplying because of the addition. So this would be log base 11. And then I want to multiply the 6 with the x minus 2 in order to combine. So that would be 6, and then I'm just going to group it for right now. And so now that I have a log on both sides, then I can just extract the algebraic equation, right? So I'm just going to pull the algebraic equation out because this is already common to both sides. So then I'm just going to distribute. So that would give me 6x minus 12, and then that's just equal to 45. I could also exponentiate it, right? Like if I made this a power on base 11 and this a power on base 11 as well, the log 11 would cancel with that. And then from there, just solve for x. So I'm going to add 12 to both sides. And then divide by 6. And that won't divide evenly, but I could divide by 3. So I'm going to go ahead and just divide both sides, or numerator and denominator, by 3. So that would be 3 goes into 5 once with 2 left over. So 3 goes into 27 9 times. And then 6 divided by 3 is 2. And then I could just leave it like that. Okay. All right, and then let's do one more here. Let's take a look at number 28. So this one's the same idea as 27. So I want to combine the logs first. And so, but in order to combine these two logs, because I have a subtraction, that means I'm going to be dividing. So I would have log base 5 still, and then I combine these though through division. So left over right, and then just equal to 2. Oops, negative 2. Okay, so now for this right here, I have to get rid of the log this time by exponentiating, just because it doesn't have a log on both sides, right? There's not a log 5 and a log 5. So to get rid of this log 5, I'm going to make this a power on base 5. And do the same thing on this side. So 5 log 5 are inverses, so that will cancel. And then I have 12 over x plus 2. And then 5 to the negative 2 is the same as 1 over 5 squared, which is 25. And then I want to solve for x, so I'm going to multiply both sides by 25 and x plus 2, and then 25 and x plus 2. So then that cancels, and that cancels. So I have 1 times x plus 2. And then I have 25 times 12. So let me get my calculator for that. So 25 times 12, that's 300. And then now I will just subtract the 2 over. And so x would equal 300 minus 2, which is 298. Okay? And that's the last page of the final review.